So let's talk about section 6.2. Now with 6.2, this is going to take us back to modeling, but we're going to look at it with cubic and quadric functions. So that's what we're going to do is we're going to model cubic and quadric functions. Before we get into cubic and quadric functions, the first thing I want to do is I want to remind myself of what cubic graphs look like. Remind yourself with cubic graphs, we have that in behavior. Again, it may have been a minute. So this is where you have one side up and one side down. Again, it can be either side up or either side down. I don't know what's going on in the middle. But what I do know is that there's two turning points, or there could even be zero. Okay, so if I just like put these together, there's not actually a turning point, but it could be like something that does this. So it could have two. Okay. Now with that also we have quadric, and this is where we have both ends are up. Okay, so both sides can be up or both sides can be down. There's going to be 3 or 1 turning point in these. Okay. Now with these also, we do have our modeling and our functions. Remember that the calculator will not give you the exact equation with everything rounded perfectly. So what you'll have to do with a lot of these is you have to kind of make note of the standard form of a few of these. So to start off with this one here, you've got your standard form of a cubic. Again, I know we're dealing with cubic because again, the highest power of x is raised to is 3, and it's going to say y equals ax to the third plus bx squared plus cx plus d, and that's going to be my cubic. Now the standard form for a quadric is actually y equals, and again, it's quadric, so that means I know it's going to be to that 4th power there. Okay. Now, with that being said, there's a big word note up there because there's a reason for this. So the standard form is actually y equals ax to the 4th plus bx to the 3rd plus cx squared plus dx plus e. Now, when the calculator is going to spit back out a quadric model, they can't put that all on the screen. So you'll notice that's going to say y equals ax to the 3rd plus bx squared plus dot 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 plus e. So they're hoping you catch that pattern, and you have to remind yourself that that dot 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 that I'm highlighting there is actually going to be these two missing terms from the standard form, which is that plus a cx squared plus a dx. Okay. So it actually stands for something, so you kind of want to make sure to keep that in mind. Okay. Now, the other thing is that we've been dealing with models since the beginning of the course. So reminder that we use the words models, we use the word regression, and we also use the word best fit. So like if I asked you for like a best fit line, that was going to be a linear regression. So I could actually ask for what's the best fit cubic model or cubic function. So I could have used those words as well. You may want to pause and write this stuff down if you have a TI-84. This is kind of summing up every type of regression that you saw. Again, these are being repeated from what we have. Again, this is from my TI-84s. You'll notice again up here at the top, I put 84 up here, okay? So first thing you're gonna do is hit stat, edit, and then you're gonna enter in everything you have in list 1 and list 2. Okay, if you have any list in there prior, please clear them. Whatever you do, do not delete the list. Always clear out the list. Okay. And then what you're going to do is after you've got all the data in and you've double checked it, you're going to hit the stat button again, and then you're going to arrow over to the calculate menu, and then you're going to select whatever regression model we're doing. In this section 6.2, there's a lot of different regression models that we do. Okay. Now, once you're in there, this for those of y'all that have the TI-84, it will come up with this beautiful pop-up menu, and just make sure that it says list 1 and list 2 in the right locations. And then if you would like to restore the equation, to do that, you're going to have to hit that whole, put the little blinker down here where the story reg equation is. Reg EQ is, and then you're hit alpha trace 1, and that will put in the Y1 where you need to, and then arrow down to click calculate. And then you're just going to rewrite the equation by substituting in what those A, B, and C values are. Now, if you have a TI-83, the steps are very similar, except for right around step 3 and 4, it just makes a slight turn. So I went ahead and wrote those down just again in case you guys forgot. So here's my TI-83ers. Again, what you're going to do is you're going to hit stat, edit, And then you're going to list all your stuff in list 1 and list 2. This is not anything new. Again, we're going to hit, once we've got all our data in there, hit the stat button, arrow over to the calculate menu, and select your regression. This is the point that you kind of veer off for my TA84s. So from there, what you're going to do is you're going to hit, you have to tell the calculator that it needs both list 1 and list 2. And basically what you need to hit is second 1, comma, second 2. Don't put the parentheses, they're not highlighted. Okay, so like those aren't buttons that you actually hit, but just make sure that those are in there. It should look something like this when you've got it in there. Just take off this part, okay? So you can kind of finish right there. So if you want to just hit enter and skip down to 5, you can. But if you want it to store the equation, you guys have that option too. It's just a little bit more work for somebody that is doing this one, okay? And let me pop up my calculator there. Just so you guys can see it here. And so for somebody who has a TI-83, so you hit that stat, calculate, select your regression. Let's do number 6, our cubic. Okay. Now, for those of y'all that have the TI-84, you're good to go here. But for those that have my TI-83, yours would have popped up looking like this. And so basically you just hit second 1, comma, second 2. And then at this point, you can hit enter and be done with it. Now, if you want it to store the equation, you at this point will hit the comma button and then the vars button. And now everything is all about just arrowing. So you're going to arrow over to y vars, hit enter for y1 for function, and then y1 is in there, and then you've got it in done and it will work, okay? Be a little cautious as you guys are doing these, and we'll talk about don't just assume it's like these numbers in the front. Always check for the back because some E's are going to start to show up. But be sure that you write down all the different values that you have for A, B, and C. Okay, so let's actually do a function itself. Let's actually try this out. And to start us off here, what we're going to do is you are going to, if you want to, pause the video, plug this all in your calculator, and we're going to find a cubic model that gives you the number of Americans working full-time. Y is going to be in millions, and as a function of their ages, whereas X is the ages. And we're going to report the model to 3 significant digits. Now, I'm going to actually highlight that because that's really important to make note of. 3 significant digits in the coefficients. That does change. This is a very special type of rounding, and I do want to point out what that actually means. Okay, so let me pull up my calculator. Okay. And we're going to hit stat, we're going to hit edit, we're going to plug in all our data, verify that all the data is good. Okay, mine's good. I've done it ahead of time. If you need to pause it and put it in, go ahead and pause the video and put them in. Okay, once you have it all in there, we're just going to hit stat, arrow over to calculate, and then we're going to do a cubic. Okay, because it told me cubic. Again, it said cubic model. That's how I know I'm going this route here. So number 6. Now, because you can arrow down and hit it here and hit enter, or you can just type the number 6 and it will work just as well. Okay, list 1, list 2, this is good to go. Frequency list, I'm not going to even store it, so I'm just going to leave that blank and click calculate. Okay, and so here is what we come up with. Now, this right here is going to make a huge difference. Okay. And I cannot stress that enough. So that makes a massive difference that will change our game here. Okay. So why does that make such a big difference? And let me pull up my pen so I can really be cautious about that. Okay. So everybody saw that we got A equals a negative 3.61616. And then it had like an e to the negative 4, right? Okay, so realistically, this number is actually a negative 0.00036161616 ... because it does kind of repeat that the whole time, right? Okay, so you'll notice again, make note of those e to the negative 4, like that's very important because that actually changes what the number starts with there. Now you'll notice none of the others had that, so I did want to just kind of like keep that in mind as I was looking at it. Okay, so there we have it. Again, I would write down what A, B, C, and D are. I'm going to focus on A and B just so I make sure that you guys understand the 3 significant digits part. Okay, Now, B itself was that kind of 0.0400995671. And then we had our C, which was at like negative 1.3898823. Doesn't really matter. Okay. Now, and then our D. Oh, since I'm going to the next slide anyway, I'll go ahead and write them all down. Okay, so 3 significant digits. Now this is the part that's like super important to kind of make note of, okay? So what I'm going to do is I'm going to actually highlight to kind of bring apart what I mean here. So 3 significant digits. A significant digit is a number that is basically 1, 2, 3, 4, 5, 6, 7, or 8. 0 is not considered, and 9, sorry. 0 is not considered a significant digit unless it's between 2 other numbers. So with this A here, again, making note, very important to catch that E, okay? E to the negative 4 makes a huge difference. So what that does is that changes the number here, and then I won't start counting numbers until here. So 1, 2, 3, that is where I'm going to round. So I'm going to round the number here. Okay, so like on this B here, what I would do is I would not start counting until I hit the 4. Again, first number that's not 0. So 1, 2, 3, and again, I'm going to round everything up to that point there. Notice on C here, we start with a negative 1. Again, that's something other than 0. So I start counting here. So 1, 2, 3. So this is where I'm going to round that one. And again, this one here is 1, 2, 3 significant digits. So I'm just going to round to here. Okay. Now with that rounding on those, one of the things, again, as you're rounding them, okay, you will need to take note of the number that's outside of this. So this 6 is going to round this up. Okay, this 9 is going to round this up. This 9 is going to round this up. And that 7 is going to round that up. Okay, so we get our actual answer is that negative 0.000362 plus a 0.0401x squared minus a 1.39x plus 21.7. And again, this was that kind of interesting thing again with that whole 3 significant digits into the coefficients, okay? Again, I'm going to pull the calculator over so you can see it does look very different than what we originally have it there. Let me make it a bit smaller so you can see it down there. Again, this does not look like the number that I saw up here, but again, as I'm looking at that e to the negative 4, that's why it doesn't start till it's way back here. And again, same thing with this one. And it's not that we're rounding 3 decimal places, it's 3 significant digits. So you'll notice that on this one, we've got the first 2 have a lot more decimals than the last 2. So that's why take good note when it says 3 significant digits. Very, very important to note that. Okay, so we're going to graph the unrounded model from part A with the same axis with the data, and we're going to look and maybe comment on how it fits, okay? So remind yourself, this is where that if you stored the equation, that is going to allow me to do the unrounded model. So if you didn't store it, so remember stat, arrow over to calculate, down to number 6 here. And then this part right here where it says store reg equa, this is where you want to hit that alpha trace and number 1 option there, okay? And then calculate. It won't show anything different, but now when you go into y equals, it will actually have the unrounded version. So it shows a lot more decimal places than you are going to be able to enter. You'll notice this shows a heck of a lot more decimal places than what it originally showed us. And then we'd also still have to turn our stat plot on and then zoom 6. Or sorry, actually, we don't want zoom 6 because we just put data in there. So we want to actually hit zoom 9, zoom stat. Okay. Okay, so we can see our pretty data there. That's what it looks like. Again, you've got your calculator and you can see that same thing here. What do you guys feel like? Does it look like it fits the data or not? It doesn't hit every single dot perfectly, but it does at least hit most of them. And it seems like it's kind of modeling that flow somewhat well. So I'd say visually, it's a pretty good fit. Okay. Now, is that to say that this is a perfect fit? Visually, yes. Data wise, it may not be. And that's going to involve a lot more business and science and math courses to figure that out. Not really science, but math. But for us right now, because we're kind of entry level math, we want to kind of keep it just kind of like, does it actually visually look like it works? And it's pretty obvious, like it hits pretty much most of the dots. This is the only one that kind of skims it, but at least skims it enough to where the rest of them are hitting as well. Okay, so we're going to take the model and we're going to use that to estimate the number of Americans working at age 59. And again, we're going to round our answer to the nearest whole number here. Okay, now we're going to estimate the number of Americans working at age 59. So basically, remind yourself that when you put all this data in the first place there, the very, very beginning when we put all our data in, we said X was our ages of people, and this is not needing to make any changes because it's not a year. So if it was like a year, like say 1960 or 2015, then yes, I would need to change it. But in our case here, we don't need to. Okay, so realistically, all we're doing is plugging in 59 and plug 59 in for all the X's, and you should end up with about 5 million there. Okay. Now, again, it does say round to the nearest whole number. So as you're doing that, be a little cautious that if you're using your calculator currently right now, remind yourself that your calculator currently has this function in, and you don't want to use the unrounded version. It does say use the model that you use this model. And so make sure that you're paying attention to that. Okay. So let's try another problem, again, looking at these here. So the number of US adults with diabetes is projected to increase rapidly in the future. And the projected numbers for the selected years in millions are shown below. Now, be very cautious that as you're going through these, a lot of the times in the instructions, it's going to tell you normally in like part A, what is going to be your 0 year. Now, I'm going to go ahead and just write it in is basically X is the number of years after, and we're going to use 2015 as my 0 year. Okay, so since that is my 0 year there, we are going to need to do a little bit of math and readjust those. Now, remember, you're never going to plug in 2015 into your list. You should plug in 0 there. Go ahead and pause the video if you need to, and let's plug those numbers in. Okay, so welcome back, and you've got all your numbers in. Awesome. Your list should look something like this down here. So here's my list 1 and list 2 put together all there. Okay. Now we want to create our stat plot. So go ahead and hit that second Y equals and turn on your plot. And don't forget to hit zoom 9 to create that full scatter plot there. Okay, so I've hit second 9. Here's my scatter plot. As I'm looking at this, this is looking kind of nice, right? It's looking pretty cool. Again, this is basically the number of millions of US adults that actually have diabetes. Now, I'm beginning to notice that this is not a perfect straight line. I mean, it's pretty straight, but it's not perfect. Okay, so that's kind of one of those things. So what I want to do is I want to do a few different things with this. So the first thing is I'm going to create a linear. Okay, and so we're going to do that first. So let's do our linear. Okay, so remember, you're going to go back in, hit stat, arrow over to calculate, hit number 4 for linreg. And again, this is what you've got for your TI-84s. You're just going to put list 1, list 2, and then click calculate. And again, for my TI-83s, go ahead and put list 1 and list 2, and then hit enter. Okay. Now, when your model comes up, go ahead and round it. Now, remember, you're going to round to 3 significant digits. Okay. Go ahead and pause and make sure you're running this, and then let's see if you got the same thing that I'm rounding to. Okay, so the answer I got was y equals a 1.74x plus 40.5. Again, remind yourself that you start counting at basically at the first number that is not 0. So anything that is a 1, 2, 3, 4, 5, 6, 7, 8, or 9, that is what's going to help you with that. Okay. Okay. Let's do the same thing with the data, but this time, guys, I would like you guys to use a cubic. So let's do the same thing, but run a cubic function. So again, remember, you're going to hit the stat button arrow to calculate, but this time we're going to use cubic. So we use number 4 for linear. Let's use cubic this time. Again, for my TA84s, you're going to see this beautiful pop-up menu. And for my TA83s, you're going to see this menu. Just make sure to say list 1, list 2. Okay, I'll give you guys a second. Go ahead and plug all that in. Pause if you need to. And run the regression. And go ahead and round it to 3 significant digits. Okay, so you should have gotten the cubic function that was the best fit for the data is basically a 0.000697 to the third minus 0.0486 x squared plus 2.64x plus 37.5. Now we did both a linear and a cubic. So let's take a look at both of those side by side. Okay. So now that you see them side by side, here is our beautiful linear and here is our cubic. Now, just by looking at these graphs, now, again, it's a little hard to see them side by side like this. Those of y'all that have a TI-83, you're probably not going to see them as nicely because you don't have color options. Those of y'all that have the TI-84s, that have the color option, there is a way for you to possibly make that show the color there. And as you take a peek at that, maybe you saw something and maybe you can see this. But in case you didn't, here's them popped up here and you can see them together. And take a peek and take a guess. Which one do you feel like is better fitting in the data? When I say better fit, like which one hits the most data points? So I'm noticing that on the linear, we kind of have a data point that's not even being hit. And then when I look at the cubic model looks like it hits a little bit better. It looks like it almost hits all of them like through the middle almost, which seems to be a little bit better in the options. So if I were asking you the question, determine which one is the better fit, my answer would definitely be the cubic seemed to look like it fit the data a lot better. The linear one was pretty good. I mean, visually, it looks really good. There was only maybe one point that it didn't actually touch the line itself, but other than that, like everything else is pretty spot on. However, the cubic looks like it almost fits everything exactly. So I would say the cubic was the better fit for that option. Okay, so let's try this again. And again, this is basically what all of your homework is. This is literally what this section is all about. It's just playing around with the calculator and really kind of learning how to deal with these types of functions. Okay. So very important to kind of play with them and see what's going on with all the different shapes of the graphs. Okay, so what we're going to do is we're going to take all of this data here, which is a lot of data. So guys, just be aware, this is a lot of data. And I want you guys to create a scatter plot. Okay, so normally when you see all this data here, remind yourself that there's normally a couple of multiple points of questions that come afterwards. So we're going to create a scatter plot for the data, and we're going to use the X being the number of years after 1900. And then we're also going to use a percent as the output for Y itself. Okay, we're going to find a cubic, we're going to do a quadric, and then we're going to take a peek at all of them put together. So what I'm going to do is I'm going to show you back all the data there. If you need to, go ahead and pause the data and let's take a peek at this, okay? Guys, be aware that sometimes the data does come in like this format here. And this has been switched into, instead of seeing it as a bar graph, we're doing kind of more the modeling, which means we want lines. Okay, so hopefully you've got this all in. So you've already paused it, you've done that. And let's go take a look at what our different things look like, okay? I'm not going to show the calculator side of this again, just because you guys have seen it multiple times now. But you can check your answers and hopefully you're getting answers that are very similar to what I got. So the first thing I asked you was create the scatter plot. And so here was our pretty scatter plot. As you can see, it does look like a little crazy there. So that does happen. Okay. And again, this is where when you hit that zoom 9, it does all this mess for you of trying to figure out what window is going to be best fit. Okay. Now, the second thing I asked you to do is go find a cubic model. So if you need to still find your cubic model, go ahead and pause it and find your cubic model. Okay. So if you've unpaused, you're now back. Here was the cubic model. Now, as you guys can see, I went ahead and graphed the cubic model with the model I have. And as I'm looking at this, this does not look like it fits very well. Again, I'm noticing here's my points. And as I follow my points, like this is what they look like. And the model doesn't look like it hits doesn't really even hit many of them. Okay. So I don't know if I would say this is a good model. Okay. Go ahead and pause again if you need to get to the quadric model next. So the quadric is going to be next. Okay, so if you've done the quadric model, again, I went ahead and graphed it with the points. And as I look at this one here, I'm beginning to notice, okay, this is the quadric model versus what I had for the cubic model. Now, question D was just basically which one's the better fit. And again, this is kind of where you need to look at both and really kind of look at them together. So I would say the cubic didn't even look like it fit very well. I would say the quadric is the better fit for the model itself. Okay. Okay. So just a couple of things again with your homework itself. As you're doing these in my math lab, one of the things you'll notice is you see this kind of button right here. This is actually going to be something you're going to need to click, and it's going to come up with all the data that you're looking at. Okay. So this is kind of one that gives a lot of data, and it's going to ask you to create a scatter plot where X equals the number of years after 1945. The second thing I want you to begin to notice, especially with these ones that have big data here, notice how it goes from basically in increments of 5. Okay. And then like magically, it's no longer increments of 5. It went to like an increment of 4. So just be very cautious as you're doing these. Make sure that you don't kind of get in the habit of like, oh, it's just always going to be 5. And then you come up with something that's not. So just be very, very cautious there. Okay. Now go ahead and pause this if you need to. Put all your data in. And then I'm going to show you kind of what A, B, and C happen to ask us on this problem. Okay, so hopefully you've had time to put all your data in. If you need to, go back a couple of seconds and look at the pause there. So what we want to do is we want to create a scatter plot. Okay. We also want to find the cubic function that models the data itself. Go ahead and round it to 5 decimal places. And then in C, I want to use the function to estimate what the CPI would be in the year 2015. And again, big key thing here, do not round until the final answer, meaning use the unrounded model. So here's basically what my scatter plot is. Okay. And again, as we can see here, this is kind of the points that I'm looking at. Okay. Now I went ahead and graphed it with my cubic function so you can see it together. It doesn't look perfect, but it's somewhat okay. When I ran my regression, this is my regression. Again, make super note of this. Does everybody see that? E to the -4, very important to make note of that. So that means there, I've got to be very cautious. Change that before you do your rounding. Now it does say round to 5 decimal places. So when I actually round this one to 5 decimal places, it ended up, when I throw this E to the -4, that was basically a 0.000. Okay. So definitely kind of be cautious there. Very important there. Okay. And then when you do your rounding itself, just kind of make sure you're rounding to 5 decimal places. And then basically this is kind of the last one I got. Again, there's a model, so it just doesn't even look that great of a model, but it happens. But what I want to do is I want to use it for the year 2015. Now, guys, do remember that we didn't actually plug in the years. We plugged in the number of years after 1945. So before I can do any of that work, you are going to have to figure out what that is, which is going to give me 70 years later. And then I can plug in 70 to predict what the model is going to be. And in my case here, it ended up predicting to be about 236%. Okay. Again, just be very, very cautious as you guys are doing this. It's very easy to make mistakes. And again, the calculator is going to do most of the work for you. You guys aren't going to do most of it, but just make sure that you know back at the very beginning those how to plug this in the calculator.